in the previous session, we learned about what is a probability, okay, what are the types of random experiments we have, what is a sample space, and an event. Now, let us move on to the next level. Probability of occurrence of an event. When you can find probability of an event, in order to know how to find the probability of an event, you should know what is sample space and what is an event. Okay, we have already learned about that. Now we will apply that in this formula. So it is nothing but every event is a subset of a sample space. That is what we have learned earlier. You have all the outcome in the sample space. Out of that sample space, you take one subset. That is, you have 1 comma 1, 1 comma 2, 1 comma 3 in a sample space. Out of that, you take 1 comma 1. That will be your event. So that is nothing but n of e by n of s. Okay. So probability of an event will be n of e by n of s. So probability of A will be equal to number of favorable outcomes to A by total number of outcomes. That is nothing but you toss a coin, okay, the probability of getting head, that is n of e, and all the outcomes will be n of s, that is n, that is head and tail. That is two outcomes you are going to get. Okay, so which will be equal to 1 by 2. Okay, when you roll a dice, the probability of getting a even number, so even number is nothing but 2, 4 and 6 in tossing a rolling a dice, so that will be 3 by 6. Okay, so this is what a probability of an event will be explained. So in the next slide, we will see what are the results, okay, in probability, what are the results which will support you in solving the problems. So probability of sample space will be always equal to 1. That is the first result. And the second result is nothing but 0 is less than or equal to probability of an event, that is less than or equal to 1. Your probability of an event, the range of finding probability of event will be always between 0 and 1. Okay, here in this slide you can see when you divide 1 by 2 you will get 0.5. Okay, similarly when you find the probability of any event, that will be between 0 and 1 only. It will not be below 0 or it will be above 1. It will be always between 0 and 1. Okay, so what is the probability of a null event? Probability of null event will be always equal to 0. It means finding, for example, even prime number greater than 3. Okay, so you are going to find the probability of event, that is you are going to pick a number that is a prime number which is greater than 3. That is not at all possible, so that will be a null event. So probability of null event will be equal to 0. Okay, so the fourth result is for any event A and B, when you find probability of A union B is nothing but P of A plus P of B minus P of A intersection B. That is, for all the probability of A and B, you are subtracting what all it is, what all the events that are common in A and B. So that will be a probability of A union B. Okay, so now for A complement, probability of A complement will be equal to 1 minus probability of A complement. Okay, you have universal set, you take what all it is in universal set, you will take it out for A complement. So that is basically, that is the idea of this result. Okay, these are the 5 important results. Now we will see a basic problem in probability. Okay, the first question is tickets numbered 1 to 20 or mixed up and then a ticket is drawn at random. Okay, what is the probability that ticket drawn has a number which is a multiple of 3 or 5. Okay, so here by the question itself we understand the sample space is nothing but 20 because the number is 1 to 20. Now we are going to find what is the probability that the ticket drawn, the one ticket which we are going to pick up will be multiple of 3 or 5. Now let's see the solution. Sample space is nothing but 1 to 20. Let E is equal to getting, now our event will be a multiple of 3 or 5. So 3, 6, 9, 12, 15, 18 are multiples of 3, 5, 10, 15 and 20. 15 is already common for both, so we can just take it once. So 5, 10 and 9. When we count the multiples, it is nothing but 9 events you are going to get in total. So probability of an event is equal to n of e by n of s, that is 9 by 20. So this is our first problem and it is a very simple problem. Next, we will move on to the next problem. A bag contains 2 red 3 green and 2 blue balls. 2 balls are drawn at random. What is the probability that none of the balls drawn is blue? Okay, so before getting to know about this solution, we will deal with the previous problem. Whenever you have picking one card or one ball or one item from n item, it means you can directly jump into probability. But whenever an event is occurring more than two times, okay, or you're going to select an event which is more than two in from a set of n items, you go for combination. Okay, now we will see the solution here. So total number of balls here is 2 plus 3 plus 2, that is 2 red plus 3 green plus 2 balls will be equal to 7. Here from 7 balls we are going to take 2 balls. Okay, that is the question. What is the probability that none of the balls drawn is blue? So that is a basic idea of this question. Now our sample space will be 7C2 because here we are selecting 2 balls. If it is just one ball, we can just apply the formula P of A is equal to E is equal to N of E by N of S. Here we cannot apply that directly since we are going to select 2 balls. The combinations may be different. Okay, out of 7, we can select 1 and 2, 2 and 3, 3 and 4. So there are n number of selections. So we go for NCR formula, that is equal to n factorial by n minus r factorial into r factorial. We apply that formula for this 7C2. So when we solve 7C2, we will get the answer as 21. Now here event is we are going to draw 2 balls, that is not going to be a blue ball. So this blue ball is going to get rejected. So we just have 2 red and 3 green. Out of this we are going to select. So we just have 5 balls. Out of this 5 balls we are going to select 2 balls. That is our event. Okay. So when we solve this, we will get answer as 10. Now we can substitute that in the formula. Probability of event will be equal to n of E by n of S. So that is n of E value is 10, n of S value is 21. So this is how the combination rule is applied in probability when the selection is greater than 1. Okay. So let's move on to the next problem now. In a box, there are 8 red, 7 blue, and 6 green balls. Here, the question is one ball is picked up randomly. What is the probability that it is neither red or green? Okay, so here the question is given very promptly and perfectly. Here, you're just going to select only one ball. In previous problem, you have taken 2 balls. So, the 2 balls will come under combination. Here it is just one ball. We can do it directly here. Now the solution is total number of balls will be 8 plus 7 plus 6, that is equal to 21. Here the ball should not be red nor green. So we are rejecting 8 red and 6 green. We just have 7 blue balls. So our n of E will be equal to 7. Our n of S will be 21. So we can apply that in the formula. Probability of an event is equal to n of E by n of S, that is equal to 7 by 21, that is equal to, when we simplify, that will be 1 by 3. Okay, I hope you understood all the problems based on combination and where we can use combination, where we cannot use the combination. Okay, we will see some more problems in the next video. Thank you.